So hello guys and welcome back. So basically my videos have been a bit late because from today, like this video itself, I am starting off a 100-day question series for the toughest JEE Advanced. Okay, you might have read the title. So basically what I will do is in this series I will take each day one question. Okay, not more than one. We will take one question each, and my target is like I am not trying to predict the JEE Advanced paper because doing that is something which is beyond limits. So I will not try to predict the JEE Advanced paper, but yes, the questions that I will do here will be really difficult pertaining to our JEE Advanced level, and my target would be to like prepare you who is watching this series for the toughest questions that have been ever asked in JEE Advanced. Okay, and I will try to cover every single topic present in our syllabus in this particular series. So it basically starts from today, and today our question will be based on limits and inequalities. And like basically I should not say only limits and inequalities, bit of definite integration too. Okay, like today's question I should mention, today's question is actually taken from an IIT Bombay mathematics paper. Okay, and this question is something that you have never seen before, I can guarantee. Okay, I can guarantee you haven't seen this before. Like this question, I will give you a small disclaimer. This question is going to trudge a bit long. This question will be really difficult. But like I don't think basically that JEE Advanced will ever ask you this level of a question. But 2016 paper had this kind of stuff. Okay, like not so long as this particular question, but it had similar stuff with this similar level of difficulty. So my advice would be that rather than, if you can solve this thing, very good. Like see, if you want to try this out, the question you have already seen it in my thumbnail, but still if you want to try it out, I would target that you can take a screenshot of that question from the video itself, close the video right now, go and try this out in a couple of 2 or 3 days. Okay, in a couple of 2 or 3 days, because this question is difficult. Then if you are not being able to, like, see, four options which are given in this question, right? They are like four different questions. So try out each option. It's basically like you have to prove, you have to not prove, I'm sorry, each option has to be solved separately and you have to check the validity of each option, something like that. Okay, so I guess you have understood. Okay guys, so I guess without further ado, we will go on to our question today. I will bring the question for you guys. So here's our question guys, and this question might look simple but is not simple. Okay, this might look innocent and simple but it isn't. Like you can understand from the options itself, the values they have given in the options, they are not something that will come from a particular expression, a general expression or something. You have ln here, you have a fraction here, you have cosine inverse here, you have n square ln here. This cannot come from a single expression. Okay, so guys, I guess I will not wait because like see, this question will take a lot of time to solve. So if you want to solve this, please take your time and solve. Okay, you can close the video and go, come and watch the solution later, but still. Okay, so I am beginning. So our s is given out to be ln of 1 plus half plus 1 by 3 up till 1 by 100. Now if you have watched my videos, you know that this is something which is called harmonic number, right? This is actually the harmonic number h100. So we will deal with that later on. And something else is also given, that Tn is equal to 1 by ln of pi r equals to 1 to n r square by 1 plus r square. And now actually we have to choose the correct options. Now in each option inequalities are given. So basically when inequalities are given, in like even in definite integration also, if you see JEE Advanced PYQs, there in inequalities we have to choose bounds. Okay, bounds meaning that the quantity is bounded with between a maximum and a minimum value. So we have to choose bounds. So if we need to choose these bounds, first we have to find out the bounds for Tn, and similarly also for S, which are not mentioned in the question. After finding them out only we can proceed, right? So that's why we can go for finding out the bounds first. So I will do that in the options itself. So guys, first off, let's go off for our option number A, which says that Tn is greater than 4n by n minus 1 whole square minus n squared ln 4, right? So actually, we will prove this using two different methods. This will come out to be correct. Okay, we will prove using two different methods. So basically, first thing is, let's write down Tn. It's given to be 1 whole divided by of ln pi from r equals to 1 to n r square by 1 plus r square. Now, just do one thing for a while. Take this expression out, like we will simplify it step by step. First, let r equals to 1 to n pi r square by 1 plus r square. Actually, we can write this thing like, if you know the properties of pi, we can distribute pi between fractions in the numerator and denominator. So pi actually r square will result to n factorial whole square. I hope this is pretty clear, right? Like it's 1 into 2 into 3 into 4 into 5 into dot 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 up till n whole square. So it's n factorial whole square. And in the denominator, pi from r equals to 1 to n 1 plus r square. And now we have ln, so what we will do is we will substitute ln into this, like on both sides. So this will be r square by 1 plus r square, and the RHS right hand side will come out to be 2 times of ln n factorial, and this will actually become minus of sigma, like, because ln, you know that when we substitute ln into a multiplicative factor, it changes to a summation factor. So r equals to 1 to n, and this thing will be ln of 1 plus r square. Okay, so guys, I'm changing the page because I have no space here. Okay, so this thing is our final expression, and now actually what I'm trying to do is we want to find out the bounds, right? So let's study each of these terms present in the expression first thing. And now, one thing that I hope you all will know, this inequality, x is less than equal to ln of 1 plus x is less than equal to x whole divided by 1 plus x. I hope all of you know this particular inequality. We are actually going to use this inequality here. It will be very useful. Like, see, if you want to actually know where did I get the idea for using this particular inequality, then I can give you some insight. Basically, first thing is x by 1 plus x came from here. It's r square by 1 plus r square. Actually, in substitution, we will substitute in place of x r square a few steps later. But for the time being, like, I hope you have done questions like this. There is a question I remember in RD Sharma or Cengage somewhere where we have to, it was, I guess, in differentiation, in your maxima and minima. There we had to prove that ln 1 plus x minus x is an increasing function. Okay. You take g of x, you differentiate g of x to g dash x. And similarly, this thing is also a very common question. This part and this part both are common questions. Okay. And if you want to know how did this come, then basically r square by 1 plus r square from here gives you an insight. I used it, and like, this is actually a standard inequality, okay, in IMO level. But still, if you guys don't know this inequality, then I would recommend, please remember this. My recommendation, because like when you get highly tough level sums, you won't have time to derive all this, okay. This is actually not derivable. This comes from standard results. Like, one is ln 1 plus x minus x is an increasing function. Another is ln 1 plus x minus x by 1 plus x is a decreasing function, like that. Or x by 1 plus x minus of ln 1 plus x is an increasing function. Also, you can say that like that. Okay. It comes from those standard results. So if you want, you can remember this. Like, we have a sine x by x and tan x by x. They are inequalities we remember. In that form also you can remember this one. Okay. Anyways, so what I'm going to do is I can write ln of 1 plus x. This thing is actually, okay guys, actually I did a mistake. I'm sorry. This is, I wrote the exact opposite. Okay. It's actually because the time is a little bit at night and I'm feeling a bit sleepy. So anyways, this thing is opposite. Okay, x greater than equal to ln of 1 plus x greater than equal to x by 1 plus x. Okay, please correct it. So guys, I am doing something. I am taking ln of 1 plus x, like writing one part, the left side part of the inequality, which is less than equal to x. And now we can write from here that ln of 1 plus r square will be also less than or equal to r square, right? So if we substitute minus on both sides, or rather not substitute, that would be a wrong word, multiply minus on both sides, the sign will be inverted, minus r square. So what you will actually get is, like, if we take this thing was in our denominator, right? This ln of this thing 1 by this thing. So if we take dn, a function which is 2 ln n factorial minus of sigma r equals to 1 to n ln of 1 plus r square, then actually from this particular equation we can write that your dn will be greater than or equal to 2 ln n factorial minus sigma r equals to 1 n r square. How? Basically I just put a sigma on both sides, then you will get this thing as ln n factorial whole square, which you will write as 2 ln n factorial, and after that I wrote dn, because dn is equal to 2 ln n factorial minus sigma r equal to 1 ln of 1 plus r square. Like first I put sigma on both sides, then I added 2 ln n factorial to both sides, so this side becomes dn, and this side I get my first bound. Basically this thing is the lower bound, okay, because it's a greater than equal to, so this expression will be your lower bound. Okay, and similarly using this part of the expression, the right hand side of the inequality, we will find out the upper bound also. So let's do that. So now we will write ln of 1 plus x is greater than or equal to x by 1 plus x. Okay, so minus of ln 1 plus r square will be less than or equal to, because minus on both sides, so r square by 1 plus r square. I just jumped one step. Okay, I hope it's comfortable. So in a very similar way, if we do sigma on both sides once again and add 2 ln n factorial, then you will again get dn is less than or equal to 2 ln n factorial, and this thing will be minus of r square by 1 plus r square, and I'm sorry, a sigma with that. Okay, wait, I will write this clearly, just a minute. Yeah, now this is okay. So we have actually got our lower and upper bounds, right, for this particular inequality. So now what we can actually do is we can write something. And what is that something? Basically it is 2 ln n factorial minus of sigma r equals to 1 to n r square. This thing will be less than or equal to dn, will be less than or equal to 2 ln n factorial minus of sigma r equals to 1 to n r square by 1 plus r square. Okay, so I am changing the page and writing further. Okay guys, so actually I wrote out this expression, which was our target expression. Like, not target expression, we have to compare, right? So now if I take reciprocals on both sides, what this will become is 1 by 2 ln n factorial minus of sigma r square by 1 plus r square less than equal to tn, which was our final expression given. And this will be 1 by 2 ln n factorial minus of sigma r square. So this is actually the inequality bound for the first Tn term. Okay, this was very important to derive, and now we will start concluding. So basically, if you keep increasing n to plus infinity, okay, or rather in simple words, if you keep increasing n, then you will observe that your dn, it becomes more negative. And the reason is that both these bounds will become negative. I mean, they will keep becoming more and more negative. So if they become more and more negative, if dn becomes more and more negative, then tn will also become more and more negative, right? It will start becoming more and more negative. So, and the reason for this is I will write this in a bracket, sigma r square. This will actually progress more than ln n factorial, the value, okay? Like you can put, actually the reasoning is from random values. You can put random values and see, like if I go 1 and ln 1 factorial, then 1 is greater than 0. If I go to 1 plus 2 square, 1 square plus 2 square, then it is 5 and 5 is greater than 2. If I next go, then 5 plus 3, 3 is 9 plus 5, 14 will be greater than ln 3 factorial, which is 6. So you can see the values are increasing, this side is increasing much more than this side, right? And when the n value tends to become much higher, then this thing will become much more greater. So that's the reason actually that this particular value keeps on becoming more and more negative. And one more thing, if you see our right hand side, 4n by n minus 1 whole square minus n square ln 4. Now the value of ln 4, actually it comes out to be, I guess, just a minute guys, I will write this down here. So the value of ln 4, actually it is 2 ln 2, so approximately I guess it is something close to 1.38. Let's take 2 decimals only, okay, not further. So actually this thing would become 4n whole divided by your n minus 1 whole square minus n square times 1.38. Now if I do a little bit of approximation here, like 1.38 is very close to 1, right? So n square minus 2n plus 1 minus of n square times 1.38, this will come approximately, very approximately, about 1 minus 2n, right? Like I'm treating these two as equal in the approximation. So 4n by 1 minus 2n. Now thing is, when our n keeps on increasing, you can understand that the denominator will become negative. The denominator will become negative. But it will become negative although, but thing is that 4n is also dominating here. Like for example, if I consider a random value, say I take n as 100, okay, say, so this will be 400 by 1 minus 200. So I guess 200 minus 1, 199. This is approximately minus 2 point something. So you can understand that the value is not very much. Now if on the other side you go on to our dn, okay, if you go on to our dn and put values on both sides, say if I consider this part only, okay, just analyze this part, you will understand. Say if I put n as 100, so r square will be 100 times, like not 100 times, square till 100 natural numbers, and this is ln of 100 factorial. So 100 natural numbers sum will be greater than ln of 100 factorial, obviously. So this thing would come out to be negative, right? The denominator would come out to be negative. So actually the thing that would occur here is that, like, doing all this calculation and estimating this value, the main purpose of this was that Tn, the growth of Tn would never be more than the growth of this particular RHS. Like see, both are negative, okay? The left hand side containing Tn and the right hand side containing this particular expression, see my pen, both these expressions are negative. But the thing is that the RHS will never be more negative. I mean, the RHS will always be less negative than Tn, right? Like RHS will be something like minus 2 and Tn will be something like minus 4, and obviously minus 4 can't be greater than minus 2. That's what I am trying to say. Okay, I am repeating once again. RHS will be less negative than the LHS, Tn. That means that Tn will never be greater than this. It will always be less than this. Okay. Okay guys, wait. I did a mistake. Just a minute guys. Yeah. Actually, I told you the reverse way opposite. Basically what is happening is, like, I did the correct calculation and I spoke the opposite. Okay, please forgive me for that. Basically this option A is correct, and the reason is because you saw I calculated 1 by this thing. So 1 by 2 ln 100 factorial, ln of a big value. Okay, but thing is that sigma r square, like the sum of natural numbers, sum of 100 natural numbers, this thing would be much more than ln of 100 factorial. So 1 by this thing would come out to be a huge value, obviously, because the difference is huge. If this thing is much greater than this, the difference would be huge, but negative. So 1 by a huge number which is negative would give you minus of 0 point something, minus of 0 point decimal places something. Okay, like it's a small negative value. You can understand, right? Like you can take any scenario, you will always see that this value would be minus 0 point something for very large n. Okay, you can take any large n, you will see it is minus 0 point something always. If you take very large n, as I said, n is tending to plus infinity. So in that particular case, if you see our RHS is actually more negative than the LHS, which means that Tn is actually greater than the RHS. Okay, I did this using this bound. If you actually put this bound also, you will realize that for both bounds it is like something of that sort, minus 0.68. Tn will lie between minus 0.68 and minus 0.64. And on the other hand, RHS would be something that is really huge. I showed you. Like if you compare minus 0.6 something with minus 2 point something, then obviously Tn is greater, right? So in that particular regard, option A actually becomes correct. Now this was one method for estimating option number A. Now I will show you a second method also. Basically here what we did was we estimated a little bit using values. Now second method that I developed is purely using algebra, no values. Okay, we did a little bit of number manipulation here, which was also logical because it made things crystal clear for us, right? So I'm showing you the second method. After that you will enjoy. Okay, so actually we will use our previous results. Okay, so for that I'm actually writing down dn once more for you. Dn is the 2 ln n factorial minus of sigma ln of 1 plus r square. So from here actually we can tell one thing, that dn is equal to 1 by tn. So if you see our target expression that we had to reach, tn greater than RHS, actually the thing we need to prove, okay, the thing that we need to prove is n minus 1 whole square minus of n square ln 4 is greater than 4n times of 2 ln n factorial minus sigma r equals to 1 to n ln of 1 plus r square. This is the thing that we need to prove. Okay, I like treat this as independent, that we have not solved it already using a previous method, that we have to see whether this statement is valid or not. Okay, so for that thing actually I will use the same results once again. Ln of 1 plus r square will be greater than equal to ln r square, or I can say that your ln of 1 plus r square will be greater than or equal to 2 times ln r. Now if we put sigma on both sides, then actually this thing will become greater than or equal to 2 ln n factorial. Okay, now dn, this thing is equal to like 2 ln n factorial minus of sigma ln of 1 plus r square, right? So comparing from this particular inequality, like I actually repeated the steps I did before only, nothing much different. Okay, but you can treat this as an independent method. So basically if you analyze dn, this particular expression here, if you start putting values, you will see dn is less than equal to 0. You will see that, and reason being, why less than equal to, if you put 0 in place of n, 0 factorial minus sigma ln of 1 plus r square, it is summing up to 0. So 0 factorial is 1, 2 ln 1 minus ln 1 will be 0, right? So that's why I have written less than equal to 0. So in this particular expression, the inequality that we wrote here, the RHS is non-positive. Why? Because the bracketed expression in the RHS, which is dn, is negative. And n is obviously 0 to something. So, and that's why actually I said non-positive. Okay, please note, I didn't say negative. I said non-positive. Non-positive includes both 0 and negative. Okay, language is important here. And one more thing, if we talk about our LHS, it is negative. Try putting a few numbers. Say, guys, actually, I don't need to prove this to be negative. I have already proved it, right? That's why I said this method is nothing very, very unique, but still, little bit different. Like we proved there itself in the previous step. I hope you have seen that this part, the denominator, it was there in the denominator of the resultant RHS. It was negative, this particular thing. So LHS is negative, but it grows as n square. That's the important thing. This thing grows as n square. And the reason is that, like, if this grows as n square, now try to understand, grows as n square will mean that this particular part, like I am coming to the original thing again that we did previously, this particular left hand side is actually less negative than again this particular right hand side. Like just cross multiplying that particular thing, we eventually got the same result. Okay, because this thing grows as n square. Grows means it grows as n square doesn't mean grows towards the negative side. I mean grows towards the positive direction, growing towards a more positive value. More positive value means less negative value. So this particular part actually grows towards n square. So it is growing towards a less negative value than the RHS. So obviously it will be greater. So from this inequality also we can prove our option A is correct. Okay, I hope this was clear. So guys, we have just found one option, don't worry. Still a lot of things are left. And let me tell you, this was a multiple correct choice question. So absolute nightmare. Okay, let's go on to option number B. Okay guys, so option number B here. And for option number B, I would like to remind you something that we had done in our previous videos. And if you are a new viewer, then I will tell it also. Hn was given to be sigma k equals to 1 to 100 1 by k, right? We can write it like that, 1 plus half plus 1 by 3. So actually this thing is called h100. This was actually our s, I'm sorry. S was given to be equal to h100. Okay, like hn is actually called harmonic number. 1 plus half, 1 is actually h1, 1 plus half is h2, 1 plus half plus 1 by 3 is h3, and so on. So once again, as I said in the beginning of our question, we have to find out bounds to solve this. So to find out our bounds, we have to bound this harmonic number also. This thing is called harmonic number. We need to bound harmonic number also. So somehow our target would be to derive harmonic number out of something. So for that, I am taking a really, like, this thing was asked once in JEE Advanced, so you would be maybe familiar about this. So I am letting a function f of x to be equal to 1 by x. Now, if there is a number k which belongs to positive integers, then actually 1 by k plus 1 will be less than 1 by x, will be less than 1 by k. Right? I hope this is pretty obvious. Like what I'm trying to say is here k is, I'm not sorry, k not x. It is belonging to k to k plus 1. So in that particular aspect, this thing holds true. Right? So now what I am doing is I will be integrating all this particular inequality completely from k to k plus 1 on all the three. So integral k plus 1 to k, I'm sorry, not k plus 1, k to k plus 1, smaller to bigger value, dx by k plus 1 is less than integral k to k plus 1 dx by x is less than integral k to k plus 1 dx by k. Okay, so actually what you would receive is 1 by k plus 1, because k plus 1 minus k would come and that is 1. would be less than your ln of k plus 1, because dx by x is ln x, minus of ln k, and this thing would be again less than 1 by k. Okay. So now after this, I am taking sigma from k equals to 1 to n terms on all the sides. Like you would have many questions like why I am doing this. Then to answer all this, I would only say one thing: we want to bring out the bounds for Hn somehow. And that's why I am doing this, okay? Like it's all based on your own intuition. Sigma k equals to 1 to n, here it is 1 by k. So guys, I am changing the page because I have no more space. So guys, actually if you see this thing, it's 1 by k plus 1. So if I put k equals to 1 here, this will be half plus 1 by 3 plus 1 by 4. So actually I can write this particular part as hn minus 1 plus 1 by n plus 1. Because the last term would be 1 by n plus 1 anyways, but minus 1 is actually not there. Like n is actually sigma 1 by k equals to 1 to n. But here 1 by n plus 1 is an extra added term. So we added that because it's coming here. And minus 1 was not there. So we wrote minus 1 and then we wrote hn. So it's completely adjusted. And for this middle part, actually this is a telescoping series. I hope you have recognized it by now. Ln 2 minus ln 1 plus of your ln 3 minus ln 2. So they keep getting cancelled like a telescopic series does. And at last we would have ln n plus 1 minus ln 1. So ln 1 is 0. So you will have ln n plus 1. And this thing is less than, this is directly your h of n. Now guys, I am going to do a very small approximation. Okay. As we keep increasing n, this particular value would become negligible because it's 1 by n plus 1. So I am writing, because it's an inequality, right? Like if it was an exact value, then maybe we could have thought about approximating a little bit. And because it's an inequality, I don't think it's a problem. Because this value will automatically become negligible and will not affect the inequality too much. So I will approximate this to hn minus 1 less than your ln of n plus 1 less than hn. Okay. And now actually one more thing is left to be done and you will have your final expression ready. So for that, what I'm going to do is I will write down the two sides of these inequalities. Please be careful. So for that, hn will be less than on one side 1 plus ln of n plus 1, and hn will be greater than, ln of n plus 1. And now guys, I hope you know one more approximation I'm going to do here. This is a very common approximation, okay? You do this in physics too. Because we are trying to create the bounds in such a way such that they are very tight. Tight basically means, like say I am bounding one value to 2 to 4. Okay. I am bounding one value to 2 to 4 in open brackets. But then I see it's bounded, like I don't know the exact value, so I have bounded it in between 2 to 4 open brackets. Just a random value, an example. Now say some person comes and tells me that I have found the exact values for this, and the minimum value is this and the maximum value is that. So actually if we take those values now, the bound becomes more tighter, more accurate, because some unnecessary values are getting like excluded, right? So in mathematics, what we try to do is we try to tighten the bounds so that our inequality comes to be more and more perfect. So for that particular thing, actually, this approximation, you have used it often. Ln of 1 plus n is approximated to ln n. You have used this very often. Okay. So I'm going to apply that here. So from that, actually, this expression becomes h of n is less than 1 plus ln n. Yeah. So I will rewrite the expression now. I am changing the page. So guys, this comes out to be ln of n plus 1 is less than of h of n is less than 1 plus ln n. And now actually our job is done. Why? Because if you put, like not put, first thing is, okay, let's put the value of n equals to 100. So ln of 101 is less than h of 100 is less than 1 plus ln 100. And now take ln on both sides. Okay. Okay guys, I actually came back here because I had done a mistake. This is h of 100, but s is not this. S is ln of h of 100. Okay, I forgot the ln. So please, I hope you have mentioned, or I mean noticed that. Okay. Anyways, let's go back. Okay. So this thing is actually your ln of 101 less than h of 100 less than 1 plus ln 100. So what I'm now going to do is I'm taking ln once again on both sides. And now actually ln of h of 100, you get s. So this is our final bounds, the bounds for s. Absolutely final bounds for our expression. If it was in n, we could have found the general one also, but because we are given 100, so we are going with that. So now guys, this particular part that I am going to do now is very important. Like you would really wonder how we are going to do ln 101, ln 100, so much calculation in the exam hall. Okay, I will keep this very limited. I have tried to use as much as limited amount of values, pre-needed or pre-known values. Like logarithm values is something that you should know. So I am trying to use that as minimal as I can. Okay, so watch this. What I'm going to do is, if we notice our ln 100, this is pretty easy to calculate actually. This is 2 ln 10, right? And 2 ln 10, everybody knows this is 2 into 2.302, which is approximately 4.604. This, I guess, you don't have to like remember any values. This is like everybody knows, okay? And now if we want to estimate ln 101, ln 101 will be, if this ln 100 is 4.604, then ln 101 will be very close to this. So I am, as per my logic, I guess it will be something like 4.61. Very, very close, but still far. Okay. So from here, your 1 plus ln 100, it approximates to 5.604. And if you want to approximate our ln of, okay, ln of 1 plus ln 100, then this comes to be ln of 5.604. And in case of ln of 101, it comes out to be ln of 4.61. Okay, so I hope this was clear. So now we can write ln of 4.61 is less than s, is less than ln of 5.604. And like, one thing that everybody, even kids, will know is that because ln is an increasing expression and 4.61 is less than 5.604, so if we put ln on both sides, the sign of the inequality still remains same. Okay, I hope this was really evident, like I don't have to mention this explicitly. So that's it, and now we will go on to the RHS of what was actually given in our option. So guys, in our RHS, we had 100 by 99 ln 50. Now ln 50, like 100 by 99, it is 1.01 something. And ln 50, like I am trying to do it as much without calculation. Okay, you can see ln 5 plus ln 10. And now ln 10 is something approximately, like we know that 2.302, right? 2.302. And ln 5 will be near about 1 point something. So I guess this will be 3 point something. This part. So 3 point something into 1.01 something. Okay. So this value would be 3 point something, right? Like very obvious. So if this value is 3 point something in the RHS, and if you see this value, this is ln of 4.61 and ln of 5.604. Okay, I circled the wrong one. See this. Ln of 4.61 and ln of 5.604. And now as much as I know and any student will know who has studied logarithms in their class 9th and 10th, ln 4.6 and ln 5.604 will be something 1 point something. Anything 1.4 maybe, like I can't tell you the approximate value because I have also not done like that, like 1.4, 1.7, something like that. Okay, let's take 1.4 and 1.7. It will be 1 point something obviously. Okay, something, these two values will be in between 1.7. So obviously the value which is lying in between s, it will also be 1 point something, say 1.6 as per my example. So 1 point something will obviously be less than 3 point something, which means that your option B was correct. S is less than 100 by 99 ln 50. Like guys, this is the height of how difficult a question can become. Okay, I incorporated everything that you have learned in calculus. Not only calculus, I incorporated even calculations. And you saw I didn't calculate so much. All I used was basic common sense and basic knowledge of functions. Okay, basic knowledge. Like this is the height of what JEE Advanced can do. Okay, maybe they will not give you all the 4 options, but they could give you even one option to solve. They could frame anything using this. Okay, they could give you even one option to solve. Maybe they will give you only this option. They will give you s and they will give you 4 options: s equal to, s less than, s greater than, s and something else, s equal to, less than, greater than 100 by 99 ln 50, and last option s greater than ln 50, something like that. So that also becomes a question, right? This is 4 questions punched into one. It's a bit big, but that is also possible. So that's why actually this question is a great learning experience for you guys. Okay, so I am going on to option C because sum is not still over. Okay, so guys, in our option number C, basically Tn was given to be less than, I'm writing the RHS here, we will need it, 2 divided by n into 1 minus ln 2 minus of cos inverse 2n by 1 plus n square. So guys, let's take this also to be equal to dn. Okay, so actually in our dn, if you observe cos inverse of 2n by 1 plus n square, this is a trigonometric term. So with your basic knowledge of inverse, you can write this as 2 tan inverse of 1 minus n by 1 plus n. I hope I don't have to explain this. So when n becomes greater than equal to 1, actually this thing becomes negative. Okay. So if this particular part becomes negative, then actually dn, it becomes greater than 0. So if dn becomes greater than 0, you would start thinking that maybe this, like, see, if dn thing is greater than 0, because your cos inverse 2n by 1 plus n square is less than 0, including the minus here, this thing would become greater than 0. And 1 minus ln 2 is obviously greater than 0, and multiplied by n, it is more greater than 0. So you will think that maybe this option is correct, but it is not. Okay, you will think in this direction, I know. That's why I found the flaw first and then I'm going into the solution. So guys, actually I manipulated this value wise. This particular logic will be only applicable for n equals to 1. Only for n equals to 1 this logic will be applicable. That's why I say it's very difficult actually to get a general method for n to solve such questions. But that's my opinion. Don't go for putting values, because if you were that guy who put only n equals to 1 and didn't go into putting n equals to 2 or 3, then you would make this question correct, I mean this option correct, and then you would get a whole negative after solving a and b. Okay, it's not correct. If you see anything which is n greater than 1, you will see that this inequality is not getting satisfied. I mean tn less than this thing will never get satisfied. Okay, I hope you understand. So at n greater than equal to 2, I can write n greater than 1 as n greater than equal to 2. I'm writing the reason. Cos inverse 2n whole divided by your 1 plus n square. This thing grows faster than your n times 1 minus ln 2. Okay. And so that you guys don't have any confusion, I am showing the graph for this. Okay. Because you might think that why is this growing faster? It actually grows faster. Like cos inverse function will obviously grow something faster than 1 minus 0 point something, which is again 0 point something times n. And if I multiply the n with 0 point something, it will go on decreasing, decreasing, decreasing. But still, I am drawing out the graph and showing it to you. Okay, just a minute. Okay, so guys, this is the curve for g of x. G of x is actually x into 1 minus ln 2 minus of cos inverse of 2x by 1 plus x square. So actually if you differentiate this, you will know the nature of the curve. And guys, if you see this part carefully, actually 2 and 3 will not be the roots, but there will be roots in between. I mean, here will be one root on the left hand side of 2 and on the right hand side of 3, because if you solve this particular equation, you will actually get a horizontal tangent here, I guess. Okay. Anyways, like, this is just a type of estimation I have done. I hope the graph is almost correct. We are not going into much of solving this part because it's not included in our question. I just wanted to make you understand. Okay. So you can see the denominator is continuously increasing. So guys, I guess we have no further doubts that the denominator is increasing very, very much, which means that Tn will be less than this. Okay. Your RHS. I'm not writing that again. And for that, guys, actually, please remember one thing. I didn't mention it here, so don't think like Tn is less than RHS out of the blue. How did it come? Tn is negative. Okay, I'm not writing the bounds. We have proved the bounds in option number A. There, Tn was found to be negative, while RHS is always positive, I guess. Like x times 1 minus ln 2. Yeah, I think it's always like for positive. Okay, we are considering for n greater than equal to 2, and there we are in the starting for n equals to 1 it was satisfying, but for n greater than equal to 2 is not satisfying. So you can actually cancel this particular part of the curve out. Yeah, just look beyond this white line. So for that, actually it's increasing, so no risks of getting a negative value. So guys, I guess Tn is less than RHS is very, very correct. Okay, so option C. Wait a minute, guys. Wait a minute. Okay, guys. I actually did a mistake. Ignore this. By mistake, I said C is correct. It is not. Okay. Don't worry. I'm explaining it again. Like, this is a really difficult question. Even I am getting confused at times. Anyways, guys, actually what happens is our denominator here was 2 by the denominator, right? And I said cos inverse of 2n by 1 plus n square, it grows faster. So we got this curve. So actually because of that, like cos inverse value and nx, you can consider it as x for the time being. Cos inverse 2x by 1 plus x square value and x into 1 minus ln 2 value. The difference between them will be negligibly small. Okay, negligibly small. Like not very small, but at least enough small so that when you divide that particular thing, when it divides the two, a large value comes. And if you actually remember in our bounds for Tn when we were calculating all those stuff, I had said that Tn is actually less than or equal to 2 ln n factorial minus sigma r square. And I had showed you that for 100, this particular value, like, not going back to all that, sigma r square is growing much more than ln n factorial, so this value is negative. But actually this denominator will become so negligible that when you compare both the values, right, this particular part will actually become more negative than the left hand side. Okay, if you want, I can take an example also. Say, what example should I take? Say we put n equals to 2. So sigma r square is your 2 2s are 4 plus 1 5, so minus 5. And ln 2 into 2 will be 0 point something, so maybe this is minus 4 point something. And coming on to the RHS, if in our RHS we put it, I guess 2 times 2 whole divided by 2 times 1 minus ln 2 minus of cos inverse 2 to the 4 by 2 to the 4 plus 1, so 2 by 5. Okay, so if we want to calculate this, let's roughly estimate this. Okay, just a rough estimation. Okay guys, so this was actually cos inverse 4 by 5, and roughly estimating this value, like, see, in the exam hall you won't have calculators, so whatever you do rough estimations, okay, but I calculated the values exactly, not exactly, that's also an approximation sort of. So actually this thing is coming out to be minus 63.7. Okay, this is coming out to be minus 63.7, and you obviously know that minus 4 point something less than minus 63.7, this is a false statement. Okay, so I guess no more further ado is left to prove that C is wrong. Tn will actually be greater than that particular expression. Okay, I hope no more ado, like I did a lot of stuff to prove it. Okay, I hope this was clear. Okay, so guys, we are almost at the end of the question, and don't worry, D will be easy stuff. So let's go on to the final estimation of D. Okay, so guys, actually D option says that S plus Tn will be greater than 4n plus 100 by 99 by 100 plus ln 4, and here an n is also there. So for doing this thing, a very simple method is to go back to what we derived just a while ago. So S plus Tn will be approximately, S was, like, I am going to my previous example, I said I bounded S in between, I guess 1.4 or 1.4 1.7 or 1.5 1.7, something like that. So let's take 1.6, okay, for the time being, it will be helpful. And Tn was a negative value, so obviously this value is less than 2, right, obviously. So now if you observe, one property of Tn was Tn is negative and increases towards the positive side. I wrote that's why, okay, so that you don't confuse. Increases towards the positive side, towards the 0, as your n grows. We have already derived this also, I am not talking about it, okay. So that's it. And let's go on into our RHS once for a while. RHS is given to be 4n plus 100 divided by 99 by 100 plus n ln 4. So if we roughly estimate this, 4n plus 100 whole divided by 99 by 100, I don't think I need to calculate. 99 by 100 is approximately 0.101. Okay, and your this thing is 2.376n. So what I'm doing is I am not going into taking this part because it will negligibly affect the decimals. So let's make this 4n plus 100. Or guys, wait. don't put this logic into the approximation. The logic you put in is, when we tend n to plus infinity, when we increase it to a very huge value, then actually this thing will become negligible in front of this, right? So we can easily approximate, and not only that, 100 will also become very negligible in front of 4n. So this will become 4n by 2.376n directly when we approximate. Nn gets cancelled. So what you will be left over is with 1.68. Because 4 by 2.376 is approximately 1.68. Now 1.6 plus some negative value is obviously less than 1.68. This is something I hope I don't have to explain. Now this was s plus tn, and this thing was your 4n plus 100 divided by 99 by 100 plus n ln 4, which means option D is wrong. This was pretty easy to prove. Okay. So guys, just a little page change in respect to this question, because this question was insane. Our correct options for this question will be A and B. Okay. So that was the end of this huge question, guys. I hope you could learn something from this, because see, these questions that I would bring in, they are not for solving out on the track and just like solving it out and you will solve it out and do it. These questions are not for that. These questions are for a learning experience, so that you learn something and you go and apply it into your exam hall in case if this comes. Okay. So that's it for today, guys. I hope you like this video. If you like this video, please do like, share and subscribe. And guys, just a small request. I saw my subscriber count has been decreasing significantly. So please, like, do support me. And guys, I am also planning to build a Telegram channel. So if we have the population increased, then I will think about that. Okay. And that will not be a Telegram channel, it will be a treasure house, because I will put in enough stuff into it so that you don't have to go anywhere else. Anywhere else means anywhere else. Okay. So that's it for today, guys. I hope you like this video, and this series would be continued further. We would come in with the day 2 of this series. Thanks for watching.